Hi everyone, welcome to your channel Impulse Tech. I am Yogesh Bhavne. So as you can see on the screen, so today's topic is all about that how we can able to use the industrial sensor with the esp32 board. So this is going to be a interesting kind of stuff that in industries there are different kind of analog input and output available. Now what are those analog input and output available in the industry? We'll see that as well. So the main objective of this tutorial is to monitor the industrial sensors data over the cloud by using esp32 board and the Blink IoT platform. So first of all, we'll see what we are going to learn in this video. First, we'll see what are the different types of analog input output available in the industry. Second, we'll see that how we can able to connect the industrial sensor with the esp32 board. Third one, we'll see how to convert 4 to 20 milliamps or 0 to 20 milliamps to the 0 to 5 volt. Now why we are doing this, I will explain you that as well. So these are the things that we are going to learn in this video. Have you ever thought how we can able to use the esp32 board in industry? And how we can able to use the industrial analog input with the esp32 board? What are the ways that we can use the industrial analog input with the esp32 board? So first we'll see what are the different kinds of analog inputs available inside the industry. Let's see. So there are two kinds of analog inputs available in the industry. One is current and another one is voltage. As you have seen in Arduino or in esp32 projects, we mainly use 0 to 3.3 volt or 0 to 5 volt varying analog input voltage, right? So for example, if you consider the potentiometer, then we can use 5 volt from the Arduino for one terminal and ground from the Arduino, and middle pin we will use as a variable output voltage. So that variable output voltage is vary in between 0 to 5 volt. So that means you are getting the analog input from the potentiometer which is range from 0 to 5 volt. That means Arduino is capable of getting analog input from 0 to 5 volt. So in industries we are having current analog input. So in industries there are different kinds of sensors available like pressure sensor, flow meter, temperature sensor. So those sensor produces 0 to 20 milliamps as a current analog output, or it can produce 4 to 20 milliamps as a current analog output. So these are the analog inputs which were not used with the esp32 or the Arduino. So in industries we are getting 0 to 10 volt as a varying analog output from the industrial sensors. So in industries we won't getting 0 to 5 volt or 0 to 3.3 volt. Now why this is so? So if you have seen any industry, so sensor is located at far end from the control room. So distance from the sensor and the control room, it can be more than 500 meter or more than 1 kilometer as well. So if we use 0 to 5 volt as an analog output from the sensors, we are not able to get the exact output voltage at the control room. That means there are very losses. So here we are going to use the industrial sensor with the esp32 board which has 4 to 20 milliamps current as an analog input. So let's see how to use it and what are the changes we need to do inside the circuit. So in order to use 4 to 20 milliamps current analog input with esp32 board, firstly we need to convert it into 0 to 5 volt or 0 to 3.3 volt. So for that we need to buy this simple small module, so which is used to convert 4 to 20 milliamps to 5 volt. As you can see, the name of this module is 4 to 20 milliamps to 5 volt converter for Arduino industrial sensor interface board. So this board you need to buy. This is the very small size board. I will show you in actual circuit as well where you can buy. So in India you can buy this is in robo.in, just 199 rupees. This is very cheap. So I will mention the link in the description box. So this is the front side of the converter module and this is the back side of the converter module. I will explain each and every component on the converter module. Let's see. So there are two kinds of potentiometer given on the converter module. One is pan and one is zero. So basically which is used to adjust the output voltage and the range that you want. Now here on the left hand side you can see you can able to give the input as a current which is 0 to 20 milliamps, or you can give 4 to 20 milliamps varying analog input to this module. So here you can see the plus and minus sign is given. So on the right hand side you can see there are three connections given. One is VCC, one is Vout and another one is ground. So VCC is basically for powering this converter module. So Vout is the output voltage that you want. That means if you have given the 4 to 20 milliamps as a current source input, then you will getting the output as a 0 to 5 varying volt output, which you can use with the ESP32 board or the Arduino. Now there are few selections you need to do. Converter module can convert 4 to 20 milliamps or 0 to 20 milliamps into 0 to 3.3 volt or 0 to 5 volt or 0 to 10 volt. So that means you are getting all the three kinds of analog input which is suitable with the ESP32 board or the Arduino. How much power supply that you can able to give to this board? You can supply from 7 volt to 36 volt. If you want the V out is 0 to 10 volt as a varying output voltage, then you should supply VCC as more than 12 volt. So whenever we power up the circuit by using VCC and the ground, then D2 indicator will turn on. So here is the anti-reverse protection which does not burn your converter. Now let's see how to adjust the potentiometer. When the current input is 0 or 4 milliamps, there are different kinds of sensors available in the industries which can give 0 milliamps as an analog output or 4 milliamps as an analog output. So you need to adjust the 0 potentiometer in such a way that the output voltage is 0 volt for 0 milliamps, or for the 4 milliamps output voltage is 0.0 volt. So when the input is 0 milliamps, then you need to adjust this potentiometer in order to get the 0 volt output. Now when the current input is maximum, that is 20 milliamps, 0 to 20 or 4 to 20, then you need to adjust this span potentiometer so that the V output is 3.3 volt. It depends upon what output voltage you want, or 5 volt, 10 volt. So whenever the current source is maximum 20 milliamps, then for example, let's say you want 5 volt as a analog output, then you need to adjust this span. Now let's see how to select the range. Now if you have 4 to 20 milliamps analog input to the converter module and you want 0 to 3.3 volt or 0 to 5 volt or 0 to 10 volt, then let's see what are the modifications you need to do. So here you can see, if you want 0 to 2.5 volt, then J1 terminal, that is pin 1 and 2 are short circuited and pin 3 and 4 are short circuited. I will explain that as well, just a second. Here you can see the terminal, that is J1 and J2 is available here. For the range selection, you need to short circuit this both the terminal in order to get the 0 to 2.5 volt as a output. So we are interested in 0 to 3.3 volt as an analog output and 0 to 5 volt as an analog output. So for that, let's see what are the changes you need to do. So the terminal J1 and J2 you need to disconnect it, and terminal 3 and 4 disconnected. So both the terminals are disconnected in order to get the 0 to 3.3 volt analog output from the converter module. And for the 0 to 5 volt analog output, you need to short circuit the terminal J1, that is 1 and 2 pin, and the terminal 3 and 4 short circuited. So these are the changes you need to do on the converter module in order to get this kind of output voltage if you have 4 to 20 milliamps as an analog input. And for example, let's say if you have 0 to 20 milliamps as an analog input to your converter module, then what kind of changes you need to do inside the converter module. So this is very simple, as you can see. So I will mention this document file inside the description box. So if you still haven't understood anything, just let me know inside the comment section. Now let's see how to wire the converter. Now I will simultaneously record the video and I'll tell you how to connect the converter module with the SMPS, which produces the output voltage of 12 volt, and how to connect the output of the converter module to the ESP32 board. Let's see. So this is the SMPS that I am using here, as you can see on the screen as well. So here the input voltage, that is 230 volt AC input, and from here I am getting the 12 volt DC output. So here you can see the module that I am using on my screen. 12 volt output from the SMPS is connected to the converter module. Here you can see I have used the 12 volt to this VCC and the ground. Now this middle pin is the V out, which is used with the ESP32 board directly. Here you can see on the screen. So the ground is common, as you can see, both for the ESP32 board and both for the SMPS. I have given the input here, that is current source input, but I don't have the analog sensors, that is which is producing 4 to 20 milliamp. So what I have done, I have created my own current source, that is 4 to 20 milliamps, by using the potentiometer. So if you want to know that how to make the own current source and all, then I have separately make one video on the same topic. So I will not go much in detail with this. Now, so here you need to connect your industrial sensor which is providing you the 4 to 20 milliamps or 0 to 20 milliamps. So here I have used pin number 34 as an analog input for esp32 board. So this connection bit complex for you, but let me tell you, this is very simple if you are getting the basics. So here you can see we have connected the SMPS which is providing us the 12 volt DC voltage. So connect the plus wire from this to VCC and connect the ground to ground of the converter module. And again connect the Vout from the converter module to the analog input pin which is 34 and connect the ground to ground of the esp32 board, and this ground should be common. So this is about the circuit diagram of this project. Now we will see if I want to monitor my industrial data on my phone. Let's say for an example, if there is one industrial person which is having 2 to 3 industries, and now he want to monitor all the industries at one place. Now he want to monitor all the industries at one place and on the mobile phone. Then how can we do that? So that's why I'm telling you this project. So if he want to monitor temperature, humidity, pressure, flow sensor or any data from his industries, then we can monitor that as well by using this converter module with the esp32 board. So we'll see how to monitor the data coming from the converter module to the esp32 board on the Blink IoT platform. So first you need to create a template in order to connect the esp32 board to the Blink IoT platform. So now if you wanted to know more about how to create template, how to create dashboard and everything, then I have already created one video on that. So I will mention the link inside the description box as well as in the I button, so you can watch that as well. So I've already created the template which is analog input. So let's click on that. So here I've created one data stream. I'm using the V0 as a virtual pin and the data type is a integer. I'll go to the web dashboard and here you can see I have just added one gauge in order to show the analog data which is coming from the converter module. So in order to configure the mobile dashboard, you need to go to the mobile app of the Blink IoT platform. So in order to add the new device, you need to click on search icon and click on new device and select your template that you have created, and let's click on adding device. So here I have already added the device. For this template, this is the device info that we need to use inside the Arduino code. So this is the code that I have already written. Here you can see. Now let's see. I have already explained you that here we are using the analog input pin, that is pin number 34 of the esp32 board. So I have declared one variable, that is sensor input, which is 34 pin number. Blink template ID, Blink device name, authorization token, you will get it from the device info. So just go to your device. So this is the template, just go to the device. So this is your device, just go to device info and just copy this code. Click on copy code, go to Arduino code, just paste it here. Now you need to provide your SSID name and password. Here I have created one function, that is send sensor. So what we have done inside the send sensor function, let's see. So inside the send sensor function, we have created again one more variable, that is analog data. So we are storing the data coming from the converter module to the pin number 34. Here you can see sensor input, which is the pin number 34. And we are reading the data and storing it into the variable, that is analog data. And also we are printing it on the serial monitor. Now we wanted to send this data to Blink IoT platform. So for that, you need to use the command, that is blink.virtualWrite to the V0 pin, that is analog data. So just write this analog data to the pin number V0 that we have already declared inside the data stream. As you can see, just go to your template, just go to data stream, here you can see V0. So we are writing this V0 pin with the analog data that we are getting from the converter module. Now inside the white setup, the rest of the part is same. Everything is same that we used to do in the Blink IoT platform. So I have compiled this code and I have already uploaded the same code. So what I will do, now I will just turn on my circuit and we'll see that whether we are getting the output or not. So as you can see on the screen, I have connected the esp32 board. So now I will turn on the SMPS and will turn on the converter module. So this D2 LED should turn on. As you can see, SMPS is turned on and the D2 LED is also turned on. I'll go to the dashboard and I'll go to the device. So here you can see this device is online now. Let's click on that. Now we are getting the analog input on the screen. What I'll do, I'll just try to vary the analog input. So I'll just try to rotate the knob. So there are not much changes because I have just used the 12 volt supply for creating the 4 to 20 milliamps. So in order to get the exact 4 to 20 milliamps, you need to use the 24 volt DC supply. So this is how we can able to monitor the industrial sensors data by using this simple converter module. So here you can see I have connected the multimeter to check out the output voltage that we are getting. So we are getting the 2.7 volt. So this 2.7 volt is going to the esp32 board as an analog input. So this is how we can able to connect the converter module with the SMPS and the esp32 board. So by using this converter module, you can easily able to monitor the industrial sensors data. I hope you found this video helpful to you. Then do subscribe the channel and like the video. Thanks for watching. See you in the next video.